Perfect. Thank you.
Okay, thank you. I hope everybody's seeing and hearing my presentation and my voice. Welcome to everybody from Belgium again. Just a few words on the content. My presentation breaks up in more or less 5 parts. The general part is on the product standards and test methods. I'm going to speak a little about sealants. Next is PU foams. We also provide some systems to the market, so a combination of products. And I will speak a little on the innovative products that we developed. Some key figures. We are a family-run business, however, 2,200 people strong. Well presented in many other countries. As we are developing building chemicals, R&D is of course very important to us. And we are investing a lot in this. This is a laboratory in Belgium. Of course, we are working together with a lot of other institutes, foreign institutes, to get the necessary or meet the necessary standards and quality labels. Now, just to make clear what products we are talking about, these are typical jointing products. Sealing and bonding is what they do, actually are used in the intersection between several construction elements, a wide variety of products, as you can see. Now, they fulfill a lot of functions in practice. Just mention a few here. Of course, airtightness is what we are looking at today, but they fulfill a lot of other functions, which lead me to say that they are an importance. Often a combination of functions is required, so these very small products are quite important. Typically, in the intersection, airtightness issues occur. As you can see, probably will not surprise you, these pictures. So we will have to keep on working on care for detail and try to improve awareness. You can, of course, manufacture very good and very quality-full products, but in the end it has to be put into practice by workers on the construction site. Okay, what are the standards for these products that we just saw? Well, there's actually not for all the products there is a product standard available, and if so, a lot of these standards are not covering the airtightness issue. For pre-compressed tapes, for instance, they have a qualification which is the BGR. But otherwise there is very little. For membranes, tapes and vapor barriers, this is mostly documented by a SD value, so the vapor tightness. Products that have SD values of several meters, up to 50, 60 or 70 or even more, are of course airtight. I would estimate that even 1 meter is sufficient to have a certain level of airtightness. Air permeability is of course, or can be tested otherwise, if not available through any product standard. And I think the most relevant norm to show or to prove airtightness of a construction element or a building component is this EN 12114. Typically, values that are measured are expressed as an A value or in square meters, or for our products, because we're talking about jointing and sealing products, per running meter. This one is expressed at 10 Pascal, but of course measuring data are available if there is a test report which can document you the losses or the air losses at other pressures as well. Also referred to by Xavier, if I'm not mistaken, is the standard for windows and doors, air permeability, linked to the 12207 and the so bespoken 4 classes. An interesting test method is the one that issued by or was written up by EFT in Germany. I will come to that later. Interesting is that this test procedure provides a method of assessment before and after aging, and of course SD values can be proven and tested according to these two norms. Now the 12,114, this is how more or less the test method is developing. You have 3 pulsations and then a logarithmical stepping up in pressure, both positive and negative. There is no obligation, however, to meet certain maximums. Mostly products are tested up to 500 Pascal or even to 1000 Pascal, depending on the required results. One method was already explained by Xavier. There is 4 classes. Why is this interesting for jointing products? Because on the right side of the graph you can see the values expressed per running meter. So this comes in handy to value the result of an airtightness test on a jointing product. We believe, of course, that staying below class 4 is what you need to, let's say, to guarantee the overall result of your construction. Class 5 and 6 are still under discussion. Now, again, for this directive issued by EFT, interesting enough, they developed a method of assessing a complete construction wall with a window installed, and so in this way a possibility to value the components that are used between the window and the wall. They actually will measure air tightness and water tightness before and after aging. The aging is written up by EFT again. They will age by temperature. They will age by functionality. So it's kind of IKEA test, if you like, opening and closing the window. And there is 3 pulsations of air pressure, repeated 200 cycles. Measuring equipment was already shown by Xavier, I think. We are down to more or less laboratory methods, which is of course not really very evident to repeat in practice, but this is how it is. In situ airtightness tests are very complicated to do. This is the on the right side you can see the Lindab small testing device, which is very interesting if you want to measure small leakages. Okay, so far for norms and standards, just one slide on emission, mostly expressed in a percentage or a rate of volatile organic compounds. Often these requirements are part of a sustainable program like LEED and BREEAM. Please be careful if you get some VOC figures. Sometimes they refer to VOC content, not emission, so not really comparable between each other. France has issued their own program. There is a measurement after 28 days, so highest class is A+. This is rather easy to achieve, as the first few days after or in curing of the product are of course the most relevant. This is why we often refer to the German standard. Products are measured after 10 or even 3 and 28 days, depending on the label that you want to acquire. The most severe one is the EC1 Plus label, on which you have a measurement after only 3 days. Okay, sealants can, of course, there is a lot of variety in sealants. They can contribute a lot to airtightness on 2 conditions. They need to stay intact, so no shearing in the product, so the cohesion has to be okay. And of course they need to stick to both sides of the other construction element to stay airtight. Important in this sense is the movement capacity they can take, because all construction joints, of course, are submitted to stress and movement. Some sealants, are parts of a combined system, and even SD values can be helpful if you want to make sure your product is airtight. But in general, most sealants are airtight, and of course, some of them are even low emission, which is a benefit in our story. Important to point out also is that since 1 year, more or less, we have CE marking on sealants, just as was the case for windows, which was introduced some more years ago. Relevant for our airtightness issue of today is the F and G grade sealants, facade and glazing. They can meet minimum requirements, but if manufacturers want to go further, want to take it further, they can have the product meeting certain movement classes, ranging up from 7.5 to 25. This is a percentage of elongation that they can take over longer periods, as shown in the drawing. So very important to check the quality of the product already. Of course, there are some general rules that have to be followed as to the performance of the product over longer periods. Of course, one of the main issues is to check substrates. Is your product okay for that kind of substrate? Will it stick to it? Of course, very important also is the joint dimension. And you can see the little drawing on the right. This is the ideal situation. Please avoid joints that are sticking to 3 sides because they will shear up in a very short time. Please also maintain a correct dimension. Don't make the joint too small because percentage-wise, it will have to take up much more movement than the maximum of 25% if you have a good quality sealant. Now, for some types of sealants, the story is quite new. Hybrid sealants, for instance, are more recent generation of sealants. They are very universal in use, very good quality. Also, the quality of hybrids doesn't vary as much, and they are quite okay with UV and to a certain extent are paintable. One of the big advantages is that they stick on even damp surfaces. Silicon sealants are there for a longer period and quite established. They're excellent on smooth surfaces like glass and metal, have a very good UV resistance, usually not paintable, but beware of lower quality. There's a lot of variation in quality in the market, so please check CE marking or other quality labels. PU has been around for many years too, very good adhesion on mineral substrate. It is, however, a little older technology, so maybe not ideal for all airtightness purposes. Very popular because of their lower price are acrylics, so please beware also of lower qualities there. But acrylics can, of course, add a lot to airtightness on the inside of a building. And please maybe check also the possible movement class that the manufacturer has issued. This graph shows the MS or hybrid polymers in comparison to other ones. For what it's worth, you can see the good adhesion on the right. Maybe interesting also is that they don't stain as much on natural stone as the silicons do. Outside sealing, typically done as in Belgium with the cavity wall construction brickwork. This is a hybrid sealant in practice. And of course the inside sealing, which is airtightness, the proper sense, is often done with acrylic sealants, very popular as I said, but they have a limited movement capacity. Acrylics will not get past 12.5% in movement capacity. If you want to have more, you can use hybrid sealants. They are paintable as well because on the inside people tend to paint the joints, but please do not forget the paint is not flexible, the sealant is. Okay, now on to PU foams. A lot of variety too. We like to tend and promote elastic foams as they will take up movement and will stay intact and keeping their insulating properties over a longer period. So our product Flexifoam was, for instance, also tested on airtightness. There is no product norm for foam, sadly enough. There are test methods issued by the industry, represented by FICA, not on airtightness. This is a voluntary testing we've done. You can see right in the below corner that the air loss is very limited. This was measured on a 2 by 6 centimeter joint, so 2 wide and 6 centimeter deep. You need, of course, some more material to make it airtight. We also performed some tests at the University of Ghent, who were running a testing program at the time, with some interesting results, ranging, as you can see in the graph, from 33 cubic meters per hour per meter at 50 Pascal, which is huge, to almost nothing. There were solutions only where we only used foam, as you can see. But just interesting, of course, is to combine products to have an extra barrier and to guarantee the airtightness over the years. So we believe PU foams can be airtight on certain conditions. You can see them here. This is interesting because you can combine thermal insulation with airtightness. Very important if you want the good results from a good quality foam is that you use a little extra water, a little moisture. PU foams are moisture curing products, and they are very sensitive to a lack of humidity, as you can see in this joint that was cut open. And this is not really the worst case, but you can see the difference if you cut up the same joint after using some water. So this is very crucial for the cell structure, adhesion, and of course for the airtightness, as you can imagine. So we had sealants and foams. We can, of course, combine some of these products. This is typically a drawing that I've taken out of the one of the test reports that we have done, or that we got from EFT in Germany, which is the test performed according to this famous MO01, as explained before, where we use 2 sealants and an elastic foam, one sealant on the inside, one sealant on the outside, and the foam in between. On the right, you can see the product that was used on the inside. This is also very low emission, which is the added benefit for this solution. Okay, now over to some innovation. We've developed a liquid membrane for airtightness purposes. This is not a water barrier. This is purely developed as an airtight barrier. We have 2 versions, one that can be brushed on, as you can see in the pictures, and this one can replace, if you like, the typical membranes that are a hassle to install often. This one is very easy to apply, just has to be brushed on. You can also use the sprayable version, which doesn't contain the glass fibers for obvious reasons. But this is, of course, airtightness at a very high speed, if you like. Both products are low emission EC1+. Just to conclude, I have some slides on how we performed the testing on these products. As I said before, in situ testing on airtightness is not very easy, as probably other people can confirm. We had the luck of finding a construction site with 2 identical windows in one living room. We masked off both of the windows and we tested it, both of them. One of them was just filled with foam, the other one with foam and the new liquid membrane, with obvious and very different results, of course. We did the test, we did the test according to the window and door norm, as you can see over here. And we did an extra smoke test to visualize the results with the Rheostream. And I think that is more or less the end of my presentation. So just to sum up, how do we, what is the quality you are looking for, or how can you guarantee that? I think you have to look for a manufacturer rather than a pure distributor of products. preferably one that has some certificates. Please go for the A brands, as A brands will have a large program on research and development. Of course, use the right product for your application. Follow the manufacturer's instructions, quite obvious. The CE marking can help you out in a basic decision on quality. Quality labels, of course, they are voluntary, can help you a lot, as can do the technical approvals for more innovative products. And I think, just to conclude, the ease of application and the time-saving aspect for us as Soudal are the best market drivers, the better guarantee for a product to be picked up, quickly by the market, as they have, of course, these obvious benefits of easy application and time saving. I don't think, maybe if there is any time, Alexander, you can start up a small video on these last products if you like, but that is the end of my presentation.
Hello, Filip. Yes, we are a little bit short of time, so I'll ask Katherine to continue with her presentation, and after the questions, if there is time, we will gladly show the video. I see that it's quite high, and only the presenter can at any time upload it. So we'll check how it works